Hello guys. So in the series of queen theory, I am going to discuss model number 1 in queen theory. So general format for model number 1 is like this: mm1 ZT infinite and infinite, where this stands for Markov process and 1 is the number of server, and GD stands for general distribution, and infinite is buffer size, and in this infinite is population size. So I am going to discuss what are the some terminologies and the formula used in model number 1. So if n is the number of customers in the system and lambda is the mean arrival rate and mu is the mean service rate per busy server, that we can also say that number of customer server per unit of time. And mu is nothing but traffic intensity or utilization factor. Mu can be represented as mu is equal to lambda by mu, as I already discussed in previous video. And LQ stand for expected average number of customers in queue, that we can write as LQ is equal to LS minus lambda by mu, or lambda by mu multiplication with lambda upon mu minus lambda. So on solving this, we will left with rho into LS. So what is LS? LS is expected number of customers in the system. So one general formula for LS is equal to lambda upon mu minus lambda. And what else is there? WS is nothing but expected time a customer spend in the system. So WS we can write as waiting plus being served time. So WS is equal to lambda S upon lambda. So LS upon lambda is equal to lambda upon lambda multiplication with mu minus lambda, and this is equal to 1 upon mu minus lambda. So what is WQ? WQ is expected waiting time per customer in the queue. So we can also write is WS is equal to WS minus 1 upon mu, which is equal to 1 upon mu minus lambda minus with 1 by lambda. So on simplifying it, we will left with WQ is equal to rho into WS. So what is ln? Ln is nothing but ln is average length of non-empty queue. So we can also write ln as ln is equal to mu upon mu minus lambda. Okay. So what is Wn? Wn is nothing but average waiting time in a non-empty queue. So we can write as Wn is equal to 1 by mu minus lambda. So these are some formulas we are using in model number 1. So basically we have to just go through it and we have to look what are the terminologies used in model number 1. So this will be helpful for to solving and identifying problems of queen theory, that it's belong to model number 1 or not. If belongs, so what formulas or what terminologies will be there, and if so, then how we can proceed with. So basically first one we have to remember here, mu is equal to lambda by mu. This is a general thing we have to remember here, and also we have to just find out what is lambda and mu. This is very important to find out in the problem, that what is the value of lambda and value of mu in the question. So if you able to do so you are easily can find out that it's belong to model number 1. If so, you can apply the formulas for model number 1. So LQ, LS and WS and WQ, so this 4 you should remember to solve model number 1 problem of queen theory. So basically if you deeply go through it, so lambda q will somehow related to lambda s, and the same thing is here for WQ is also related with, so WQ is related with WS. Here we can say that WQ is equal to mu multiplication with WS. So just write these formulas in one paper and summarize it, and easily you can remember these formulas, and by doing so you can easily solve the problem based on queen theory of model number 1. So this how I am discussing with you that concept and formulas based on this model number 1. So you go through it and just find out some useful things and note it. And thank you for watching this video.